Hello guys, today we're going to study 1.3 Models and Applications. Let's start with example 1. Starting salary for college graduates with undergraduate degree. When you look at this question, it seems really complicated. What we want to do in the end is we want to find the starting salaries for psychology major, business major, okay? We also need to find the English major. So which means we actually can give rid of ones we don't need them, like biology, right? This major, computer science. A business major exceeds that of a psychology major. So when we see this word exceeds, that means if we translate it to math, that will be a plus sign, right? So then we also have another one here, and then that's another plus sign right here. Then we look at combined, so we can translate it into add everything together, correct? So let's go ahead and set this up. From the sentence, or compare to psychology majors. So we're going to set this X as the salary for psychology major. And then we can write the business major as X plus 8. Then we can write the English major exceeds by 3,000. So that will be X plus 3. Okay, so that is how we set it up first. Once we set this up, so we're also know combine all these together give us 116. So I'm gonna write psychology major, and I'm gonna write the business major. Also, we're gonna write the English major. So we combine all these together and give us 116,000. That is how you set it up. So once we have this, the rest is easy. So once we have x equals 35,000, okay, I'm going to write K. Remember, that's what we're looking for. We're looking for the psychology major. And then we also have, we need to find the business major, x plus 8, which is 35 plus 8. That will be 43,000. And then we're going to, you also can find English major, which is x plus 3. That would be 35 plus 3 give you 38,000. Okay, that's how you solve example 1. Example 2 is a very long question. Let's break it down. So if you look at this graph, in this case, we don't care about that part. So the idea is, okay, the most important part is for the period from 1969 through 2009. So here we have 1969 to 2009, right? This percentage increased by approximately 0.9 each year. So where we started right here. In 1969 we have 42%. And then each year we're going to increase by 0.9%. So that is something very important. Let's highlight this part. We don't really care about other things, to be honest with you. So each year we have increased, if you translate to math, that would be plus, increase 0.9 per year. So we started with 42%. Okay? So the question is, by which year will all freshmen consider being well off financially? So the idea is, or this is going to be continue, alright? So this graph is going to look like continue. So here we have 42. Let's see, this is 42. And then here we have 78. So basically the idea is eventually, alright? This idea is eventually somehow, somewhere, so from this we're going to continue, and then eventually we're going to reach this 1%. So that is the questions asking you. So here is going to ask which year, right? Which year you're going to get 1% right there. You're going to have another bar. So that is the question asking you. Okay, let's go ahead and set it up. Okay, let's go ahead and set this up. I'm going to write x to b equal to the number of years after the really beginning, that was 19 1969. And then we're going to write this equation. So if this is the numbers years after 1969, we know at the beginning that was 42%. Since we're all dealing with percent, I'm just going to write 42. Each year it increased by, right? Each year increase. So that word actually goes here, increasing. That is plus by 0.9% each year. So I'm going to put 0.9 each year. The x year, that will be multiply x. But then eventually what we want to do is we want it to be equal to all the students, right? All the students, they're going to be well off financially. So that means in the end, our idea is that would be 1%. That's how you set it up. Once you set this up, the solving the equation is really simple. So which will give you around 64 years. So if we look at this question, in the end we want to ask it which year. So what we're going to do is I'm just going to use 1969, alright, after 64 years. After 64 years, you add this and that will give you the year of 2033. So basically by the year of 2033, all freshmen consider being well off financially. So that is how you solve this type of question. You just have to break it down and then get rid of all the extra stuff, the words, and then you just read the important numbers and the words around it. Let's look at example 3. I think I'm going to read the question. Realize this is asking how many text messages. So what I'm going to do is, that is what I want to set this up. I'm going to set the x is the number of the text messages will be cost for the two plans be the same. Then also there's a word same that actually translate to math, that will be equal sign. Okay, plan A offers us $20 monthly fee. So with, right, these words are translated plus the 0.05 per text. So the number of the text messages is x, multiplied by x. So then we'll also find the plan B. So plan B will have a monthly fee $5 and then with the charge of 0.10 per text. So we multiply x because we want to find the text messages will be cost for the both plan be the same. So we translate this in the middle. That will be the same. That will be equal sign. So once we have this, we're just going to go ahead and solve this equation. X equal to 300. So that is your final answer. Therefore, 300 text messages will be the cost for the two plans to be the same. So we finish this example. Example 4. Your local computer store is having a terrific sale on digital cameras. After a 40% price reduction, you purchased a digital camera for $276. What was the camera's price before the reduction? So when you look at this question, so we're going to look, they're asking you what was the original price. Well, I'm just going to say let x to be the camera's price before the reduction. So we have an original price, right? And then we also did a reduction. When you talk about reduction, the word reduction, we're talking about subtract, right? Subtract. And then we have a 40% price reduction. So we're going to have a 40%. So we said our original price was X dollar, right? That would be 40% discount. Then what you got is $276. So that is how you set it up. You had the original price, then you subtract that 40% discount, and then you're going to have this $276. So once you have this, we're going to solve this x minus, that will be 0.4 x equal to 276. 1x minus 0.4x give you 0.6x. And then we have 276. Then we divide by 0.6 both sides. So you're going to have x equal to $460. That was your original price. Therefore, the original price of the camera is $460. Example 5. So what we're going to do is, because we want to find both investments, one is 15%, one is 7%. Okay? So what I'm going to do is, I'm going to set one of them. I'm going to set x to be the amount. Okay? Just use a dollar sign. X to be the dollars invested at the 15%. Okay? If we are investing X dollars at a 15% interest rate, the rest of the money, which means the $50,000 minus the X dollar, so we're going to invest this money at the 7% interest rate. So let's go ahead and finish setting up this. So we have X invested for 15%. We also have 50,000 minus X dollars at a 7% interest rate. So because we want each year have a 6,000 income combined, so which means we're going to have an X dollar. Okay, somehow we're going to add those two investment together. You should give you a $6,000. So we're going to look at the first one. We have 15% interest rate. So we invested X dollars for the first investment, and then we're also going to invest the rest of them at the 7% interest rate, which is 50,000 minus X dollars. So we add them together, will give you the $6,000 return each year. Alright, once we have this, we're going to go ahead and solve it. So this is going to be 0.15x plus 0.07 multiply 50,000 minus x equal to $6,000. Okay, once you have this, let's just go ahead and simplify it really quick. And then you're going to have x equal to $31,250. Okay, so if you look at the question, are you done? You're not done because you only find the investments at a 15% rate. So we also need to find another one, which is at the 7% annual interest. So this is at the 15% interest rate. So let's go ahead and find another one. That will be 50,000 minus the $31,250. That will give you $18,750. Okay, that will be at 7% interest rate. So that is your final two answers. Okay, example 6. Let's go ahead and draw a graph. So here we have a football field. Okay, the football field is 200 feet more than the width. Let's make this as our width. I'm going to use W. Okay, and then our length, which means is 200 feet more than the width. When you say more, you're going to turn it to math. We're just going to add. So that means our length, okay, I'll write L length equal to 200 plus the width, right? So that's the first sentence. And then if the perimeter of the field is 1,040 feet, then we're asking you what are the dimensions. Perimeter, we know for rectangle is 2L plus 2W. So in this case, let's go ahead, because we said the perimeter is 1,000, right? I'm just going to plug in 1,040 feet. And then I'm going to rewrite it as L as 200 plus w. That will be 2 times. All I'm doing is just a substitution. So I'm going to use this substitution here. For L, you're going to have 2 times 200 plus w, then plus 2w. Now you look at this equation, we only have one variable. This variable is w, okay? It's exactly the same thing as x, you're just going to solve it, which will give you w equal to 160, okay? So that is 160 feet for the width. Because they're asking you dimension, let's go ahead and continue. So we also have to find the length. Our length is 200 plus w, which in our case that will be 200 plus 160. So we find the answer for the length, that will be 360 feet. So that is your final answer. Okay? Example 7, solving a formula for a variable. So here we have to sum the formula P equals 2L plus 2W for L. So for this type of question, I'm just going to copy it one more time down, just easy for us to see. That will be 2L plus 2W. So because we want to solve for L, so what you do is you have to treat all the other things. You're just going to treat L as your variable. Everything else is just some number, okay? Or you can treat them as constant. So here's what we're going to do. So in the past, okay, let's just say in the past you learned this before. If you P is just a constant number, so let's say P is 4, and then you have your L with used to this form. Then we have 2 times. Let's say we have 3. Right? W is 3. So you know how to solve this, right? So you're going to bring this, you subtract this 6 on both sides, then you divide by 2 eventually. So you're doing the same thing. So what I'm going to do is, I'm just going to, since it's subtract, that'll be just negative 2w minus 2w equal to 2l. Right? So again, we want to remind ourselves what you are doing, because only L is our variable. So what you done here is 4, you subtract 2 times 3. I know you can simplify. I'm just trying to show you how it works. Okay? So once you have this, because you're solving for your x, so you know the next step is just divide by 2 both sides, right? And then you cancel them. It's the same thing here. So we're going to divide by 2 both sides. So divide by 2 both sides. Here we divide by 2 both sides. So they're going to be canceled. So what you're going to have is, you're going to have the right side, you're going to have L. Is the only thing left, which is that what we want. And then the left side, we're going to have P minus 2W over 2. If you want to rewrite it, it's a little bit nicer. So you're going to have L as your variable equal to P minus 2W over 2. That is your final answer. Okay? Alright, let's go ahead and work on example 8. Again, we're solving a formula for a variable that occurs twice. So we have A equals P plus PRT. Okay? So, you know, it's nice you know what this formula for, but we just want to solve for P, okay, for right now. So we're going to write it down one more time. A equals P plus PRT. Okay? So because we want to solve for P, let me do it again. We're just going to treat this as your variable, everything else like a number. So again, make some examples. Let's say this is 200 equal to P. Let's make it the old way looking. That will be X, and then that will be X. Let's make R like 0.2, and make your T is 5. Okay? So you know you have X, X. So what you did in the past is, you're probably just going to factor the X out. Then you're going to have 1, right? Plus, this is 0.2 multiply 5 left. Correct? Of course, you can simplify this when it's a number, but since it's a letter, so you cannot simplify this. Let's just go ahead and do this step by step, okay? So because we know this, so we're going to write A just equal to, we're going to factor the P out. What left over, that will be 1 plus RT, right? So then, because we know we have to solve for P, so what we're going to do is just the same thing as in the past. In this case, you just divide by, whatever you get here, that will be 1 plus 1, that will be 2x, then you divide by 2 both sides, correct? So if in the past, you could simplify this, 1 plus this will be 2, and then you're going to have this 2x equal to 200, and you divide by 2 both sides, correct? You're doing the same thing right here. So what we're going to do is we're going to divide by 1 plus RT. This side the same thing, 1 plus RT, right? And then what happens here is this term will be canceled. So you're going to have P that will be equal to A over 1 plus RT. So which means we can write it as, again, a little bit nicer. That will be the variable on the left side of P equal to A over 1 plus RT. The main thing is you have to remember for this type of question, whenever you have to solve, you have to treat all the English letters as a constant, because you know how to do those in the past. You just do the same thing. Okay? Thank you for watching the lesson. I'll see you guys next time.